Hello and welcome. Today, we're tackling a significant consequence of our changing climate, the increasing punch packed by extreme rainfall. We're seeing more intense and frequent heavy downpours in many parts of the world. The basic science is straightforward. A warmer atmosphere holds more moisture. For every 1 degree Celsius rise in global temperature, the air can hold about 7% more water vapor. This extra moisture is like adding more fuel for potential rainfall. So, what specific weather systems are delivering these drenching rains? One major player is atmospheric rivers. These are like rivers in the sky, long plumes carrying water vapor from the tropics. When they make landfall, especially over mountains, they can unleash prolonged, heavy rain. Climate change is projected to make these more frequent and intense. Then there are mesoscale convective systems, basically, large, organized clusters of thunderstorms that can dump heavy rain over wide areas for hours. Tropical cyclones, like hurricanes and typhoons, are also part of the story. While their overall global numbers might not change much, the ones that do form are likely to be stronger, with heavier rain. Even everyday frontal systems and low-pressure areas are being supercharged by the extra moisture available in a warmer world. And yes, even smaller, localized thunderstorms can become more severe. The connection to climate change is multifaceted. It's not just the increased moisture. The entire Earth's water cycle is intensifying. More evaporation means more moisture up there, ready to fall as more intense storms. We're also seeing shifts in large-scale atmospheric circulation patterns, like the jet stream, which dictate where storms go and how strong they become. There's growing evidence that really short, intense bursts of rain, think hourly downpours, are seeing their intensity climb even faster than longer rain events. We're also paying more attention to compound events, where extreme rainfall might hit alongside strong winds or storm surges, amplifying the damage. It's important to remember these changes aren't uniform across the globe. Some regions are getting hit harder than others. For instance, the U.S. Midwest and Northeast have already seen significant increases in the heaviest rain events, and this is projected to continue. In parts of Australia, while overall rainfall might decrease, the downpours that do occur are expected to be more intense. Accurately projecting future rainfall extremes is still a challenge. Climate models have limitations, especially with small-scale events like thunderstorms. And it's always tricky to distinguish natural climate variability from human-caused climate change signals in observed trends. However, the overall message from science is clear. When researchers analyze different types of rainfall, the increase in extremes often aligns well with that 7% moisture increase per degree of warming. But sometimes, for the most destructive flash flood-causing events from mixed cloud systems, the observed rainfall increases can appear even higher than that. In conclusion, a warming climate is unequivocally leading to more intense extreme rainfall in many regions. This is fundamentally driven by the atmosphere's increased capacity to hold moisture and changes in weather patterns. Understanding these changes is crucial as we work to adapt to the growing risks of flooding and its impacts.